Hey guys, so today we're going to be simplifying radicals. So we've talked a little bit about radicals and we've graphed them, but today we're going to be starting our unit on doing operations with these radicals. So the first part of this is just listing what our perfect squares, cubes, and fourths are. So that means I take a number and I square it. I take a number and I cube it. I take a number and I take it to the fourth power. So our perfect squares are like 1, because 1 times 1. 2 times 2 gives me 4, 3 times 3 gives me 9, 4 times 4 gives me 16, 25, 36, 49, 64, 81, 100, 121, 144, and etc. So those are the ones that usually come to mind when we talk about our perfect squares. Our perfect cubes aren't really numbers that we know right off the top of our head. So like 1 times 1 times 1 still gives me 1. 2 times 2 times 2 will give me 8. 3 times 3 times 3, 27. And I get 64 for 4. 125 for 5. 216 for 6. Excuse me. 343, 512, 729, etc. And then with our perfect fourths, these are even less likely to be numbers that we just know off the top of our head. 1 times 1 times 1 times 1 is still 1. Then 2 times 2 times 2 times 2, 16. 81 for 3. 256 for 4, 625 for 5, 1296 for 6, 2401 for 7, and so on, because they get very, very large very quickly. So then on our parts of a radical, so we haven't gone into the different parts of the radical and what they're called. So the symbol itself is called a radical. So we can call it the radical symbol. The number underneath that radical is called the radicand. And that little number that goes inside the little loop there is called the index. And so whenever we don't have an index, we assume that it is 2. We know that because we're taking square roots. Then on the next part, we're going to give the total number of possible roots. So whenever it says give all possible roots, that means the positive ones and the negative ones. So if we're taking the square root of 16, I can get a positive or a negative 4. Square root of 121, I can get a positive or negative 11. 289, we can get positive or negative 17. And for when we're taking fractions, it's the same thing as taking the square root of the top over the square root of the bottom. So the square root of the top is plus and minus 2, and the square root of the bottom, plus and minus 5. Thank you! On the next one, excuse me for that, on the next one with cubes, whenever we're taking the cube root of something, we take the sign of it. So if it is a negative number underneath, it's going to be a negative number when it comes out. If it's a positive number, then it's going to be a positive number. So what I mean by that is the cube root of 8 will only be a positive 2. Cube root of 343 will only be a positive 7. Cube root of negative 125 will only be negative 5. And then here, cube root of negative 1. In order for the whole fraction to be negative, though, only one of them will be negative. So it could be either, it doesn't matter, because when we take that overall fraction, we're just going to leave it on the outside. So then the cube root of negative 1 is negative 1, and the cube root of 27 is 3. So you get negative 1/3. And when we're taking fourth roots, it's just like our square root, so we can have plus or minus, because if I take the same number 4 times, if it's negative, it's going to end up positive in the end. So the fourth root of 1 could be positive or negative 1. 2,401, positive or negative 7. 4,096, positive or negative 8. And then again with our fractions, we have the fourth root of 81 over the fourth root of 16, which would be plus or minus 3 for 81 and 2 for 16. So here we have this table that kind of breaks it down for us. If we have an even index, so 2 or 4 or 6, and the radicand, the part inside, is positive, then we're going to end up with positive and negative roots. And we'll have 2 roots. If we have an odd index, so like 3 or 5, and the number inside is positive, then we will have a positive root, and we'll only have 1. If we have an odd index with a negative radicand, then we'll have a negative outcome, and we're only going to have 1 root. And here with the star is one of our special cases, and that's whenever we have a negative underneath the radical with an even index. So that's like if we're taking the square root of a negative number, then we know, we've talked about it a little bit, we're going to end up with an imaginary root, and we will only have 1. Or 2. So we take plus or minus. Sorry, where to go there? We'll have the positive and negative imaginary. Now on the next part, this is where we get into simplifying. So we've done this a little bit when we were in Algebra 1, but now we're going to be using variables in there as well when we get to the second page here. So when we are simplifying our radicals, we want to know what the index is. So if there's no index, it's an index of 2. And that means we need 2 of a kind. So what I mean by that is, maybe once I start doing it, it'll kind of make sense. We'll get the prime factors of 117. It's going to be 3 squared times 13. If you have your calculator, it's many number factor to get your prime factors. And so that's the same thing as taking 3 times 3 times 13. So whenever we are rewriting it, anything that is 2 of a kind will come out to the front, but only for how many pairs we have. So I have 1 pair of 3s, so I'm going to write 3 only once, and then whatever's left over stays inside. So I'm going to be doing the left side of these problems. So we're going to be doing the odds together. So the next one we'll do is number 3. And on number 3 we have 2 cube root of 48. So this cube right here tells me that I need 3 of a kind. So I'm going to take the prime factors, 48, and 2 to the 4th times 3, which is 2 cube root of 2 times 2 times 2 times 2 times 3. So because that index is 3, I want to take 3 out at once. So I'm going to take that out. And so I'm left with 2 times 2. Since I already had a 2 there, I'm taking out 1 2. And then on the inside I still have 2 times 3 left over. Now we write our final answer. We're taking those numbers and multiplying them. So 2 times 2 on the outside becomes 4. And then 2 times 3 on the inside becomes 6. Now on the next one, we've got the cube root of negative 250. And so we are going to take the cube root of those prime factors. So we have -1 times 2 times 5 cubed. If I take the cube root of a number, I know that my answer will be negative. So I'm going to go ahead and take that negative out, even though it doesn't have a pair. So negative roots will give you negative answers. So I'm going to take that negative out. And then I know that because this has a power of 3 on it, that I can take it out with nothing left over. So on the outside I have -1 times 5. And on the inside I still have a 2. -1 times 5 is -5. And on the inside still is that 2. Now number 7, we have 3 times the fourth root of 162. So that means I need 4 of a kind here. So I'm going to take the prime factors of 162 and put them underneath that radical. So it's 2 times 3 to the 4th. Because this has a power of 4, I know that whole set is going to come out to the front there. So this would equal 3 times 3, 4th root of 2. That's what's left over inside. 3 times 3 is 9, and then 4th root of 2. Then when we work with variables, square roots, they're going to be multiples of 2, the exponents on them. If the exponent is not a multiple of 2, then we're going to either have everything left over or something still left over. Cube roots have to be multiples of 3, and 4th roots have to be multiples of 4. So on number 9, the index is 2. So that means I want 2 of a kind to come out. So I'm going to take the prime factors of 32, and that's 2 to the 5th, and then I still have x to the 4th and y to the 9th. So one way that you can do this, instead of having to write everything out again, oh no. Let me rewrite that, I'm sorry. So instead of having to rewrite all your variables out and saying, well, that's x 4 times, and that's y 9 times, and then circling your numbers, instead what we can do is write them as multiples of whatever our index is. So since my index is 2, I'm going to write 2 to the 5th as multiples of 2. So I can say that's 2 to the 4th times another 2, right? Because when I add those two exponents together, I get 5. I can say x to the 4th is x to the 4th since that is a multiple of 2. And y to the 9th could be y to the 8th times another y. So now when I'm taking out my powers, I'm going to take out 2 to the 4th. But I need to be aware of how many times I'm taking out 2 to the 4th. Since my index is 2, divide that power by 2, and I'm taking out 2 pairs. Same thing with my x to the 4th. My power is 2. My power is 4. 4 divided by 2 is 2. And then there's y to the 8th. 8 divided by 2 is 4. So those are now going to become the powers on those variables or numbers on the outside. So I'm going to have 2 squared times x squared times y to the 4th. And then on the inside I still have a 2 and a y. And so you can leave it like that with those dots in there. Or we can say that 2 squared is 4. And then push everything together without the dots. So 4x squared y to the fourth square root of 2y would be our simplified radical. On the next one with the 216, we're going to do the same thing. This time our index is 3. So I want to take out anything with a multiple 3 on it. Prime factors of 216 are 2 to the third times 3 to the third, and then we have the n to the third, n to the sixth. So I need everything to be multiples of 3, and we're lucky on this one that they are. So what I'm going to do is divide everything by the index. So the power by the index, 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. And n divided by 6, what? And 6 divided by 3 is 2. So then those are the powers of my variables and of my number. So on the outside, I have 2 with a power of 1 times 3 with a power of 1 times m with a power of 1 times n squared. If I took everything out of the radical, then that radical is gone. And so I have 2 times 3, which is 6m n squared. On number 13, we have the cube root of a negative number. So remember, whenever it is negative, we're going to take that negative out. We're going to find the prime factors of negative 64. We get negative 1 times 2 to the 6 times and then y21. So just like before, we want to make everything a multiple of 3. Don't know why it does that. So we have negative 1 times 2 to the third, no, 2 to the 6th, times x to the 10th, times y to the 10th. So we'll take that x to the 10th. It's the only one that's not a multiple of 3. We've got negative 1 times 2 to the 6th times x to the 9th, since 9 is a multiple of 3, we would need one more power of x, times y to the 21st power. And so we know we're taking this out, the whole thing. Divide the power by the index. 6 divided by 3 is 2. Power by the index. 9 divided by 3 is 3. Power by the index. 21 divided by 3 is 7. So that x to the first power has to stay inside since it's not large enough to take out. So we're taking out a negative 1. We're taking out 2 2's. We're taking out 3 x's. And we're taking out 7 y's. And then left on the inside, we still have that x. So I'll rewrite that by multiplying out the coefficient on the front. And so we have negative 1 times 2 squared, which would be negative 4. And then x cubed, y to the 7th. Cube root of x. And so we've got 2 more examples to go through with our fourth roots now. So just like before, we want 4 of a kind now, instead of 3 of a kind, instead of 2 of a kind. So I want my powers to be multiples of 4. So we don't have any numbers, so we're not going to take prime factors, but I am going to split these up to be multiples of 4. How can I make 17 a multiple of 4? Well, I know 16 is a multiple of 4. And to get from 16 to 17th power, I would need one more. So then the ones that are multiples of 4, I'm going to circle them and divide the power by the index, and I get 1. Power by the index, and I get 4. And then that 1 I can't take out. So I would have a W times v to the 4th, and still on the inside I would have v to the 1st power. So rewriting that, I would say, well, W v to the 4th root of v. And last one, 17. We have a number in the front, so I'm going to rewrite it using its prime factors. 5 to the 4th power times c to the 23rd times d to the 11th. So since my index is 4, I want to make everything a multiple of 4. 5 to the 4th is good. 23. The closest I can get to 23 is 24, but that's too high over. So I'm going to go one below that, one multiple of 4 below that, which would be 20. So I have c to the 20th, and left over I would need 3 more powers of c. To get to 11, the closest I can get is 12, but that's over, so I'm going to go one multiple below, which would be 8. And I would need 3 more powers of d to get to 11. Now the ones that are multiples, I'm going to divide their power by the index. I get 1 there, 5 there, and 2. So I'm taking out a 5 powers of c, 2 powers of d, and inside I still have 3 powers of c and 3 powers of d. So I'll rewrite that without the dots, and it's 5 c to the 5th d squared, 4th root of c cubed d cubed. So that's it for the notes portion, and then I have left the remaining ones for you guys, which are going to be the even problems. Make sure that you work those and get them submitted on Canvas, and then tomorrow we will be doing radical operations. So make sure that you're really good at simplifying, because we're going to get into some pretty cool stuff tomorrow.